Hello students. So today we will start the first chapter of geotechnical engineering first, and the first chapter is Introduction to Soil Mechanics, or you can say geotech engineering, and origin of soil. So this is your chapter 1, and this video is video number 2 for the geotechnical first or soil mechanics lectures, right? So let's begin. So first of all, in the subject geotechnical engineering or soil mechanics, let us first of all try to understand what is soil. See, the term soil means different things from different perspectives. For example, an agriculturist for an agriculturist, the definition of soil will be different, right? For a geologist, the definition of soil will be different. But for us, civil engineer, the definition of the soil may be different, right? So let us see, for an agriculturist, soil means the top layer of the earth which is responsible for supporting plant life. So just the top layer containing the organic matter, that is what is soil for an agriculturist. But for a geologist, soil is the thin outer layer of loose sediments within which plant roots are present. So till the point at which the plant roots penetrates, that is what is soil for a geologist. And also a geologist refers to the rest of the earth's crust as rock. You must be knowing what is crust. So rest other than the soil, they call it as rock, irrespective of how strong or weak the bonding forces of sediments are, right? But for us civil engineer, the definition will be a little different. For us, soil means all naturally occurring relatively unconsolidated earth material, organic or inorganic in character, composed of solid particles, right? Produced by disintegration of rocks and that lies above the bed rock. Now these are all terms that I am defining, or the definition of soil from different perspective that I am defining has already been mentioned in the notes that I am going to provide you, right? So here you can see that for an agriculturist or for a geologist or for a civil engineer, what does it mean? So in the notes you can see all this. I will share this note with you all. Now, so from different perspective we saw that the meaning of soil is different. Okay, let us see what Tarzagi has to say. Tarzagi is a well-known name in the field of geotechnical engineering, a scientist. Let us see what he has to say about soil. Soils can be broken down into their constituent particles relatively easily. On the other hand, rocks are agglomeration of mineral particles which are bonded together by strong molecular forces. So, from his definition, we can say that soil are easily broken into its constituent particles, but to break a rock, it's very tough. So, on this, that is the binding forces. On the basis of binding forces, he differentiates the rock and soil, right? So, I think so. The term soil must be clear to you all. Now, after knowing about the soil, let us now uh, define the term soil mechanics. See, soil mechanics is the branch of civil engineering that concerns the application of principles of mechanics, hydraulics to the engineering problems relating to soils, right? So, simply the application of the principles of mechanics, you must have studied the subject mechanics, right? Engineering mechanics in your earlier semesters. So, you have to use those principles of mechanics and also hydraulics. In this semester, you are studying this subject, hydraulics, right? So, the principles of mechanics and hydraulics you have to apply on the soil. That is how the forces are acting on the soil and how the water travels in the soil. All these principles you have to apply on soil, and this is what is called soil mechanics, right? Now, the same thing for rock mechanics, that is the science dealing with application of principles of mechanics, right, to the understanding of the behavior of soil rock masses. Right here, the term hydraulics has not been mentioned because rocks are not permeable, and hence water movement is not through the rocks, and thus the hydraulics term has been skipped here. Now, another term is soil engineering. So, what is this? Soil engineering is applied science dealing with the applications of principles of soil mechanics to practical problems, right? So, simply the theory is soil mechanics, and if you are going to apply it in the practical, for the practical purposes, it's called soil engineering, right? Now, the geotechnical engineering is a broader term, right, and it includes soil engineering, rock mechanics, and geology, right? Geology means study of the earth, under the earth, right? Geography is the outer part of the earth, the study of the outer part of the earth, the mountains and the rivers and all that, and the interior parts of the earth, when you study it, is termed as geology, right? So these are some of the terms that related to the subject, right, and that we must know. Moving further, what is the scope of soil engineering? So in the last video also I have mentioned, right, here also why we are studying the soil engineering or soil mechanics or geotechnical engineering. So when you construct the foundations, role of soil, you have to study the properties of soil. For retaining structures, you have to study what are retaining structure. In the hilly areas, you must have listened about, or must have come across the word landslide, right? It occurs. So to avoid such sliding of the land, we construct some structures like walls, so that the land may not slide and may not come on the road, right? So for that we construct retaining structures. Then stability of slopes, underground structures. When you're constructing any underground structure, definitely you'll have to know the properties of the soil, you know. And then pavement design, definitely the soil is the last material on which the road is going to be constructed. And then the earthen dams. So everywhere soil, soil, soil. So as a civil engineer, you have to know about the soil, right? Yes. Then the next topic is origin of the soil. So how the from rock the transformation takes place to soil, right? So let us consider that there is a rock. Now, when it is exposed to the atmosphere, weathering action takes place, right? and this weathering action takes place due to mechanical disintegration and also due to chemical decomposition, and thus formation of soil takes place. Let me explain this. There is a rock, right? Now this rock is exposed to atmosphere. What is the meaning of exposed to atmosphere? It means exposed to sunlight, temperature difference, wind, water, rainwater, river, glacier, all exposed to all these factors, right? Now when it is exposed to all these factors, weathering actions take place. Weathering action means breaking down, right? Weathering means breaking down of the rock. Now the two terms, mechanical disintegration and chemical disintegration or chemical decomposition, that leads to formation of soil. We will come to these two terms in a little while, right? Now let us see what is geologic cycle. It consists of, the geologic cycle consists of erosion, transportation, deposition and upheaval of the soil. That means whenever there is internal movement in the earth, that is tectonic plates, related to tectonic plates movement, earthquake, volcanic eruption, right? There is formation of reliefs like mountains, right? How all these mountains have formed? Only due to internal disturbances in the earth, right? Now once these mountains and other reliefs have been formed, the external forces like the wind, the rain, the temperature difference, all these act on these reliefs and try to break it down, right? Now when it is broken down, it is weathering, erosion, right? And then after weathering, there is transportation of this broken rocks, now which has turned into soil, and it is deposited somewhere, and wherever it is deposited there is upheaval. Now due to this upheaval, again there is internal disturbances, and again due to this internal disturbances, earthquake, volcanic eruptions do take place, right? And thus a geologic cycle is formed, right? Now there is a term, let us see what is it. Residual soil. Residual soil. Now see, there is a rock, the rock has weathered, undergone weathering, and thus the soil formation has taken place, right? Now if this soil stays at the place of its formation, right, just above the parent rock. Parent rock means the rock out of which the soil has been formed. So thus this type of soil is called residual soil, that is no transportation has taken place. And also it is possible that transportation of the soil after weathering has taken place, that is called transported soil, right? So firstly let us see residual soil. It is also called sedentary soil. The engineering properties of residual soil varies from top layer to the bottom layer. Relatively fine material near surface and large fragments of stones at greater depths. It is well expected that at greater depths there will be large fragments, because that which are at greater depth, that has been not exposed much to the atmospheric agents like wind, water, rain, right? Yeah. Now properties of bottom layer resemble that of the parent rock. What is the properties of the parent rock? The same will be the properties of the soil or rock or fragmented rock that is at the bottom layer, because not much of the changes or weathering has taken place. But at the top layer where the weathering has taken place in a very good manner, the properties will be different, right? Now there is transported soil. When soil has been deposited at a place away from the place of origin, it is called transported soil, right? Engineering properties are entirely different from the properties of the rock at the place of deposition. So simply There are two types of soil, you can say: residual soil, transported soil. Residual soil, there is a rock, the weathering has taken place and the soil has not been moved to any other place. The soil is present at the place of its formation, that is called residual soil. Transported soil, due to wind due to wind, or even due to rainfall, or even through rivers or glacier movement, the soil has been taken away from its formation point, that is called transported soil, right? Now let us see formation of soils. As I was discussing here, mechanical disintegration and chemical decomposition. So mechanical disintegration or physical disintegration, right? Formation of soils takes place in two ways: the physical disintegration or the chemical decomposition. So let us see what is this physical disintegration. Temperature changes. Now see, there is a rock, and during daytime, the upper surface gets heated. The bottom surface is not heated that much, but the upper surface has been heated. Now there is expansion on the upper surface, but not much expansion on the lower surface. Due to this expansion, plus during the night, there is not much heat and there is cold. So this, the upper surface, now there is shrinkage, but in the lower part of the rock there is not much shrinkage, right? So expansion shrinkage of the upper part. So these upper parts get separated from the rock, and this is weathering process due to temperature change. Wedging action of ice. See, there are some of the voids in the rocks, and that gets filled with water or snow. Now, as the temperature gets lowered, the water turns into ice and it expands. As the temperature rises, ice turns into water, right? So there is expansion, contraction, and this leads to breaking of the rocks. Spreading of roots of plants. So plant get germinated on the rocks, and as the roots penetrates to the rocks, there is weakening and breaking of the rocks, right? And abrasion, abrasion means rubbing of the two things. So one rocks get in touch with the other rocks due to some atmospheric agents like wind or water movement. So there is abrasion, and thus weathering takes place, right? These are the some other physical disintegration. Chemical decomposition includes hydration, carbonation, oxidation, solution, hydrolysis. You must have gone all through all these terms in your standard 12th, so you know all these terms very well, right? So how does the transportation of soil take place? It takes place with different agents, right? That is water transport. Number one is water transported soil. All types of soil carried and deposited by water are called alluvial deposits. So you have to remember this term. Now, deposits made in lakes are called lacustrine deposits. Marine deposits are formed when the flowing water carries soils to ocean or sea, right? Wind transported soil. Soil deposited by wind are known as aeolian deposits. Glacier deposits, drift or till. It's called drift or till. And then there is always possibility of gravity deposition, right? So how the soil can be transported? So it can be transported through water, it can be transported through wind, it can be transported through glacier movement, right? Water movement or glacier, and then it can be transported through gravity, right? So these are some of the ways in which the transportation of soil take place. Now the major soil deposits of India, you must have gone through in all this in your standard 10th or standard 8th in geography, right? So there are alluvial deposits, black cotton, alluvial in Gangetic plain, black cotton in southern part of India, right? Lateritic soil, and then desert soil in Rajasthan, marine soil in the coastal regions. So these are some of the major deposits of soil in India. Now, um, after this, there are some of the terms for the soils, right? You all must go through all these terms right? Like bentonite. So what is bentonite? So volcanic ash related soil, है ना? And the properties, like it is having very high shrinkage. So what is shrinkage property of soil? You don't know right now, but as we proceed ahead, you will come to know what is shrinkage and what is swelling characteristics, right? So you must know different types of soil: black cotton soil, boulders. So the 3 mm size, anything that is any rock or soil that is more than the size of 300 mm is called boulders. Definitely these are going to be stones and rocks, right? So there are also like clay and silt and cobbles, right? So you go through these notes and also through your book, and please try to get these terms in your mind. So that's it, students, for today's lecture. um, I will meet you again in the next video, and we will start next lecture from there. Thanks a lot.